about one important experiment, and it is very interesting. It is conducted by the scientist known as H. Hertz in 1887. The name of the experiment is photoelectric effect. From the name itself you can identify it is something about a photon and something about electron. Okay, photo means light, something about light and something about electrons. It is very clear. So you can see the experimental setup here. In that experimental setup you can see a clean metal surface and a detector which is placed inside a vacuum tube, and you will see light is falling on that metal surface. So what happens when light of a particular frequency strikes that metal surface? Those metal surfaces preferably taken as potassium, rubidium, cesium, etc. And when these light of a particular frequency strikes on the metal surface, electrons are emitted from that metal surface and it flows towards the detector. Okay, that means an electric current is formed, or electrons are formed and it moves towards the detector. And what is the function of the detector there? Detector counts the electrons and measures its kinetic energy. So that is the experimental setup we have to know about photoelectric effect. Then let's see what are the results or what are the observations that are arised from photoelectric effect. We check the observations of photoelectric effect or the result we could gather from that particular experiment. There are mainly three observations. One is, when that light strikes the metal surface, the moment the light strikes the metal surface, the electrons are ejected. That means there is no time difference. No, it's not like light is striking the metal surface first and then the electrons are ejected after some time. It's not like that. The moment the light strikes the metal surface, that moment itself electrons are ejected from the metal surface. There is no time lag between the striking of the light on the metal surface and the ejection of electrons from the metal surface. So it happens simultaneously, that moment itself. The moment light strikes the metal surface, the electrons started getting ejected from the metal surface. And the second observation is, the ejection of electrons from the metal surface is directly depending upon the brightness or intensity of the light. The ejection of electrons from the metal surface is directly depending upon the brightness or intensity of the light that is fell on that metal surface. And then the third observation is, in order to get, if you use a light to get it or get it strike on the metal surface, whatever be the case this light falls on the metal surface, the basic requirement is it should possess, that light that falls on the metal surface should possess a characteristic minimum frequency which is known as mu 0. Mu 0 is the characteristic minimum frequency that should be possessed by the light that is fell on the metal surface. Only then the electrons will be ejected from the metal surface. Okay, as you know, these electrons, when it is in a particular metal or atom, these electrons are attracted by the positive charge of the atom. Electrons are attracted. Some attraction is there between that is present in the electrons. So in order to remove that electrons, it need a particular energy which is higher than its attractive energy towards the nucleus. Okay, so this mu 0, that means it should possess a minimum characteristic frequency to release electrons from the metal surface, and that minimum characteristic frequency is known as mu 0. Okay, so that these are the three basic observations we could get from this photoelectric effect. And as you know, this photoelectric effect explains in a way about the particle nature of electromagnetic radiation or particle nature of light. Okay.